The following content has been provided by RWTH Aachen University.
All right, so the last part is the quantitative side of user studies. So controlled experiments. This is a much more, I would say, academic exercise, if you like. You are trying to actually get to concrete data, reliable, objective, verified data about some aspect of an interface. So not something done very often in evaluating a commercially developed tool, because you really just want to make sure that your users get through your tool very, very well, and there are no usability issues. Maybe they like it more in the end than a competitor's tool. Maybe you can show that. But if you're really interested in determining if a particular design decision in a tool, maybe a small decision, makes a difference or not, then you go to controlled experiments. And sometimes that's even necessary also in commercial applications. For example, I talked to a guy who worked at Google many years ago, and he said they have fantastic ways of experimenting on users in a way, because they can do things like change the color of advertisement that's shown at the beginning of your search results from a light yellow to a more creamy yellow, and they can do that for millions of users in a whole part of the US, for example, and then see whether that even slightly influences click-through results, responses to ads, that kind of stuff. So they have these, the fact that we have so many web-based apps these days and so many online interactions means that we can actually do big data analysis on those kinds of user interface changes. And this turns very quickly into a controlled experiment where you're running statistics and all that kind of stuff. But here, most of the controlled experiments I'm talking about are not happening at users' PCs at home. They're usually happening in a lab. So this is where your lab setting basically shines, because you want to control everything, right? So sorry, Mr. Field Study, you're not really going to be much use here. This is something that happens in the lab in a controlled setting. So what we're trying to do in a controlled experiment, ideally, is to show that some aspect of the interface, something we change about the interface, is responsible for a change, improvement in performance or behavior. So we are going to directly manipulate some variables, as we say. You know this from statistics. And we're going to control these variables in order to change what's happening. And then we're going to measure some other variables to see whether the effect was there or not. Very early on, when we talk about this, we need to probably just reiterate, because you've probably heard this before in statistics, that correlation and causality are two different things. To give you an example of what that means, let's take the following study. Making stuff up here now. This is mocked up data, so this is not a real measurement. But let's say somebody runs a study. He interviews people or observes people or records the computer use of people and finds out the average gaming time per week in hours. Okay, so 100 people all measured, like how many hours per week do they play video games on their computer or smartphone or whatever. And then there is the same number of people that have been observed that way are also taking a test in typing speed, and the typing speed of these people is measured. All right? And let's just assume for a second that we find the data to be looking kind of like this. So it looks like, as gaming time goes up per week, typing speed in words per minute also seems to go up. Now, wouldn't we all love that? That would be wonderful, right? There's finally an excuse to play video games. But when I say that, I'm already making an assumption here. I'm already making the assumption, which probably most of you have already made in your head without thinking about it, that this is not just a correlation between two variables, but you've actually probably applied something like a causal relation. You've probably thought the gaming is the reason for the improvement in typing speed, right? It's very easy to come to that conclusion. But notice that this is a separate step from just noticing the correlation. And that's important because the actual gaming per week might not be responsible for increasing the word per minute count. Even though the two are correlated, one doesn't have to be the cause of the other. Why? Well, because, for example, it could be the case that, yes, playing computer games increases your typing speed. That's one assumption that could be true. But it could also be that people who are good at typing tend to be people who just like games. And they also play more games. But the game playing isn't actually improving the typing speed. It's just a natural correlation because people have certain interests and preferences. Or there could be a third hidden factor that we don't know about. Maybe people who read well also type faster, and there are also people who tend to spend more time playing video games. I'm making all these things up right now, but notice that there are different kinds of explaining the correlation between those two data sets. Okay? And just to put this to an extreme, I could swap this graph around. It would look the same. I could put average typing speed down here and have average time playing games up here. And none of you would say that if you type more, that will lead to you playing more hours of video games each week. That seems very bizarre, right? But it could be just as true, right? The data isn't telling us. So from this data, you cannot conclude, that's the main point here, you cannot conclude just from recording this data that playing more video games will increase typing speed. That is a causal relationship that you cannot derive from this data. So that's why we do controlled experiments and try to find out where there are actually causal relationships between things. We do these controlled experiments to verify something, like an observation that we made, or a correlation, like this one, or just a hunch where we think something is going on. We have an idea that something might be related and might have an effect. So here's a quick overview of what a controlled experiment looks like. We're going to go into a little more detail on these steps in the next couple of slides. First thing you do is, obviously, you need to formulate a hypothesis. Then you design an experiment. You pick your variable parameters and the fixed parameters. You run a pilot study to debug your experimental setup. Then you choose and recruit your subjects. You run your experiment, and you finally interpret the results to accept or reject the hypothesis. You guys have all had statistics in your classes in the past. So can I hear an example for a hypothesis? What would be a hypothesis that we could ask? I mean, completely open. Anything maybe from the field of HCI in the broadest sense, but make something up. I was asking for dangerous amounts of creativity right now, I know, but come up with a hypothesis. Anything.
A red button leads to more clicks on that button.
Okay, so if we put red buttons in front of people and green buttons in front of people, people will tend to press the red buttons more often. Okay, good, that works. So there's your hypothesis, and that one you need to then sort of run through these steps.
This content was provided by RWTH Aachen University.